Hello. Cool. So I'm going to be going over SQL Joins today from a conceptual standpoint. Um, I find concepts and understanding concepts is honestly the better way to go when it comes to tech rather than just trying to memorize syntax. There's potentially an unlimited number of libraries that could be made, um, but as long as you understand the core concepts, you can generally go from language to language, go from one particular type of SQL to another type of SQL. So let's start on SQL joins. So what are SQL joins? They're a way where you basically take data from one table and you put it together with data from another table so that you can analyze the data. Um, what's the first step? Basically, figure out what tables have the data you need to analyze. If you're analyzing customers and their orders to figure out trends on orders, which customers are top customers, which customers have in the recent months been decreasing, how much they've been buying, has there been any spikes, etc. What are the patterns that matter for those customers? Can we potentially target them with certain ad campaigns? Basically, identify which tables have the data that you need. Customers table might have customer ID and customer name, whereas orders might have order ID and customer ID. Um, and you can use that customer ID column to figure out where they match. So, like which customers are assigned to which orders. Then you identify the columns of interest. What data do you want? What data is relevant to what you are trying to do? Um, Are those columns the correct data type? Do you need to convert those columns to a different data type in order to make them um, essentially to where you can put them in a sum or an average, etc. Because if you have a string data type and you're trying to sum that, that could definitely cause some issues. Um, or if you're trying to order by, but you're ordering by something lexicographically rather than um, the order that you want to order by. That could be messing things up too. Do you need to use a case function to switch it to a different value so that you can order properly? Does it say 1 in text, but really it needs to be 1 as a number so you can order numerically? Cool, you're going to have to convert that. What can you use for that? You can use a case and do case joins. And that's pretty helpful, honestly. Um, and then just know if you need data from more than a single table, or you want to get data from a table, but you need a relationship on that table, then you're going to need a join. So, what do you need to do your analysis? Do you need an average? Do you need the point? Do you need variance? Is variance already calculated? Is it not calculated? Does your data set have what you need to do your analysis? Do you need to reach out to stakeholders in order to figure out um, if your company has the ability to get the data you need? If you need to reach out to someone, who do you reach out to? Reach out to them, try to get the data you need. Be like, hey, I need this data. I don't currently have it. Can we obtain it? If you can't, reach out to the stakeholders who want the analysis and be like, hey, currently we can't do this. Is there anything else I can do to help? And maybe you have to close your ticket. Maybe you don't have to close your ticket. Maybe there's a worker. But in order to do that, you need to know what data you need. You need to know what formulas you're going to be using. So identify the specific columns in the table for your analysis. If you figure out what data is needed, you can make sure that the results actually get calculated properly without uh, wasting time making data retrieval longer than it needs to be. That'll go into optimization, but I'm going to explain optimization in a later video. So in this example, if you're looking at variance on a population, you need x sub I minus the average of the x's. You then sum all those squares and divide by the number of data points, and then use Bezel's correction if you are doing it on a sample. You need x sub I and you need the average. Do you have those in your columns? If not, can you retrieve them? Do you need to calculate them? That'll also tell you other things you need to do. If your original data doesn't have the column currently, but you need to add it, then you can alter the table and you can add another column and you can essentially add an average into there so that you can find the distance. Figure out the matching conditions. Are you going to do an equijoin, which is where you are essentially looking for data that matches another piece of data? So customer ID in the customer's table is equivalent to the customer ID in the orders table. If you're doing that, you can use left, right, inner join based on what you want to do. Yeah, so if customer ID in the customer's table is equivalent to the customer ID in the orders table, but you do a left join, you can find all the orders that don't have a customer assigned to them because the customer ID column will be null. And then that makes it to where you can look for where it's null in that table and then filter down. You can do range conditions. So range conditions are pretty useful for dates. So where the customer orders are between date 1 and date 2. Usually use the between keyword for that. Or you can use less than, equal to, greater than, equal to, and the and keyword. Defining join conditions. Join condition is essentially equijoin versus non-equijoin again. Use the on clause. On basically says, how do I glue these together? How do I put this data together? Where versus having. Where clauses are used when you are not filtering on an aggregation. A where clause is basically where this cell is greater than, equal to, less than, or matching a certain value. It'll help you filter down to stuff like that. But if you have something where you need like to filter on a sum, a count, an average, then you need to understand the difference between how you write SQL and how SQL runs. SQL essentially runs in the following order: from, where, group by, having, select, order by, limit. If you can understand that having is used to filter records after aggregation's taken place, and you can understand what that exact order, then you can understand basically this aggregation won't exist at this point. Therefore, I cannot use where, I have to use having. But if you don't understand that logical order, then having versus where can be a little confusing to some people. At least at an actual conceptual understanding level. You can memorize, use having, or where if you're using an aggregation or not using an aggregation, but the actual understanding generally comes from understanding the logical order of a SQL run. Logical order of SQL, from, what tables do I want to grab my data from, where, how do I filter it down, group by, how do I squish this together? Am I getting a sum per date? Like order total per date, order total per month, etc. That will squish stuff together, basically, and give you a final result for that condition group, basically. Having filters results from the group by to include only groups that meet specific conditions. This is where you are filtering on aggregation. So sum is greater than this. So like total profit is greater than 15,000, or variance, if calculating variance, is less than a certain amount. Select specifies which columns to display in the results. Basically, show this, show this, show this. Awesome. Order by is how you organize stuff. The reason why order by is generally written before, yeah. So essentially, the reason why you're ordering stuff, organizing stuff, you have to put it into collections first. So collect the red Lego blocks, collect the blue Lego blocks, collect the green Lego blocks. Cool. But how are we going to sort the green, red, and blue? That's what you use order by for. You can order them by size, descending, or ascending. Start with the small Lego blocks, start with the big Lego blocks, go down, go up. Limit restricts the number of records returned by the query. In certain relational database management systems, you have to deal with just syntax changes really, but it's the same concept essentially. You can either use top or you can use limit based on the database you're using, and like what it's being run in. So if you're using SQL Server, you might use something like top. If you're using MySQL, you likely use limit, return the top, return the 5 records, limit 5, top 5, etc. Handling non-matching rows. So this is one place where joins can be pretty useful. You should determine how to deal with non-matching pieces in tables. So where does this customer not have orders? Does this order not have a customer assigned to it? That's where it's helpful to understand inner joins versus left joins, right joins, etc. Inner join in this example would allow you to get all the customers who actually have orders, and it would go, cool, there's a match here, there's a match here. On the customer ID, we're going to retrieve the customer ID, the customer name, the order ID, the order date from the result set, created by grabbing from the customers table and the orders table where there is a match. And we're going to get rid of everything else basically. Left join will put all the nulls in the right table. A conceptual thing that some people don't get is a left join is just a mirror of a right join. So as long as you know which tables your left table and your right table, the left join and right join can both be used to do the same thing. So a left join grabs all the rows from the left table and gets matching rows from the right table, but anywhere there isn't a match, you will see nulls in those areas in the table. So if there isn't a customer for an order, if there isn't a customer ID assigned, or the customer doesn't have any orders, basically, then you're going to see null, 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 null in the right side. And then that lets you use where on the column that's going to have a null in it to find customers with no orders. But in this example, show customer ID, customer name, order ID, order date from customer from the result set created by customer C, and give me everything from the customers table. That's also what left join does. Left join grabs everything from the left and will show you the data. And you'll get nulls on the right. Where customer ID equals customer ID. Right join, basically just flip it. You will get nulls in the left table. You'll grab everything from the right table, but as long as you understand a right join and a left join are mirrors of each other, you can use that to your advantage and just swap the left and right table. So instead of from customer C, right join, orders O, etc. What you do is you flip those tables. You take orders, you put it where customers is, customers put it where orders, and you basically can use a right join as left join or left join as right join. Yeah, just a quicker way to write SQL if you actually understand the concept. Full outer join for nulls from both tables when you want to get all of the data, regardless of a match, basically. Um, and get nulls in both tables where there isn't a match. You can use what's known as an outer join. In MySQL, you have to deal with the fact that at least in certain versions, there isn't a outer join there, so you have to mimic it using a left join and a right join, and you combine those together using union all. Union and union all are ways of combining sets together. Union is a strict union, it won't put in the nulls, whereas union all will leave the nulls in. So on this, you're grabbing customer ID, customer name, order ID, order date from the result set created from customer C being joined by an outer join to orders. Where there's that match, you'll get nulls in the right and left where there's a match. Just a quick visual, inner join, you're going to grab only the places where the customer ID and customer ID in this table, so customer ID and customers, customer ID and orders is the same. You're going to grab that intersection. Left join, you are going to get all the data from the left table, and you're going to get nulls in the right table. Yeah, right join, you are going to get everything from the right table, and you're going to get nulls over in the left table. I did not make these visuals. These visuals were auto-generated. For full outer join, you're going to get nulls in both tables. So yeah. So the join result set represents the rows produced by a SQL join operation containing data from both tables based on specified join conditions. Inner joins, only the matching rows are going to get into your final collection of what you get. Outer joins include all the rows from both the tables, and that gets nulls in left and right table. Equijoin is basically joining where customer ID in the left equals customer ID in the right. You can also do it on other columns, but that's a basic idea. Range, like I was saying earlier, is great for dates. So if you want to grab all the customers where they're actually active, you can filter where the order date is between the sign up date and the end date. So basically how long they've actually been a customer. It can be used for memberships and other things. And it will filter down. So you're joining on order dates between these. It'll say basically put those together, but only put them together where the date is. And that'll help you filter down. Non-equijoins, so where the order date is less than the sign up date, you can filter down to where a date is less than a certain date, greater than a certain date, greater than or equal to, if you want to include that date. It's really based on the interval. So non-equijoins involve conditions that do not require exact equality, such as comparisons, less than, right, greater than, less than, equal to, greater than, equal to, and they can give better results or broader results, including overlapping ranges, other conditions that connect rows across tables can be used. So if you want to find like overlapping meetings, you can use non-equijoins. You basically just have to understand how intervals work and if there's inclusive or non-inclusive. Proximity joins. Proximity joins are good for like geographical distances or time intervals. In this example, basically you're finding the absolute value of the date difference between a certain day and the sign up day. Actually, you're finding the date difference in terms of days, because that's the unit. The sign up date and the order date, you're making sure it's less than or equal to 7. So what this will do is like, if that's negative, absolute value will turn it to positive. If it's positive, it'll still be positive. Because absolute value is just the distance from 0. So yeah, you can find all this information from the customers and the orders where the difference between the sign up date and the order date is less than or equal to 7 in terms of the day units. Because date difference will spit out a number in terms of the unit that you specify. So in this case, it'll spit out a number representing days between those dates. Join on versus where. Join on basically says glue these together right here. Where is after that? So if I could draw on this, I'd basically say circle join on and put the data together on the where on is specified basically, where customer join on customer ID and customers equals customer ID and orders. Cool, you have that. How can we refine that data set more? Use where or having to refine that more. Yeah. So here's like a quick way to think about it. What tables contain the values that one needs? Identify those. And then since it comes from more than one table, you understand you need to join. What qualifies as a match? Are you using equijoins or non-equijoins? Do you need to do a range of dates? Cool, you're doing a non-equijoin. Do you need to do a range of values? Non-equijoin. Do you need to do where they're an exact match? Cool. Do an equijoin. What do you want when rows don't match? Do you want nulls in the right table? Cool, use a left join. Do you want nulls in the left table? Use a right join. Do you not want any nulls in either? Use an inner join. Do you want it in both? Use an outer. Yeah, so all in all, SQL joins are important and it's a really, really crucial concept for people to understand. It's great when you need data from more than one table, 2, 3, 4 tables, and you just need to collect it all together into what's known as a result set, which is the data that you filtered down to essentially and put together. You can then perform aggregations such as sum, average, etc. on that result set. But in order to get the right result set, you need to understand exactly how it is going to be affected by where having left join, right join, inner join, out join, outer join. Yeah, if you understand all of that, then you're pretty good when it comes to joins. Past that, I would definitely say that if you want to understand them better, there's a thing called row explosion, which can happen when you're joining and the level of like granularity, it's called grain, isn't the same in both tables. You can generate more rows because the level of detail is not the same. If it's orders per day in one table, but it's orders per week in another, that can mess you up in terms of your understanding if you don't understand what grain is. In order to fix that, you generally use group by in order to change the units. If you understand how unit conversion works in like basic math, that can be really helpful in terms of like an analogy, turning kilograms to grams, grams to kilograms, how that works. Yeah. If there's anything else I could go over that might help improve understanding or that I didn't go into deep enough in this video, please make sure to write it in the comments and I will try to make a video on it. I enjoy just making note type videos like this where I take my notes and I put them into presentations. Not only does it help me to improve my knowledge, but it also helps me to share knowledge with other people and find places where my understanding is weak and might need more uh, of an improvement. It also just helps me to teach others and share knowledge about tech and stuff I find interesting. Um, yeah, anyways, uh, Dankeschön, Daniel. Tschüss.